Dear all, thanks for joining on this wonderful session. We will start this session in another 3 minutes. So we are waiting for some other participants to step in. So we will wait for another 3 or 4 minutes. Samyukta, shall we start?
Yes, Bhishma, yes. So, a very good noon, ladies and gentlemen. This is Samyukta from ANSET. Welcome you all for the session on configuration of DCM module. So, in our today's session, we'll be focusing completely on diagnostic communication manager and how to configure the read data by identifier services in DCM. So this is what we are going to completely focus. So just a minute.
Samyukta, you are in mute, Samyukta.
Yes, Bhishma, just a minute. Some
Yeah, no.
network issues. I'm not able to move my slide. One. Okay. Sorry, had a network issue. So now is my screen visible, Bhishma?
Yes, it is. Yes, it is.
Yeah, thank you. So the agenda for today will be the introduction to the Diagnostics Communication Manager, and as well as we are going to see how to configure the DCM module, in which there are many services. We are going to restrict ourselves to reading the data by ID service in the DCM. This is what we are going to focus today. So about this vehicle diagnostics, the role of the DCM, it will only start when the vehicle is taken to the service station. All right. Here, what happens is that the tester tool will be connected to the vehicle. Here, shown you right. Here is the tester tool, which will be connected to the car. Fine. So a tester tool, when connected to the vehicle, it will be typically connected to the canvas where the tester will be acting as a client and the ECU will be acting as the server. So we all know that tester is a diagnostic tool through the canvas. It will be reading the data from the ECU. Data in the sense, it is not only the data, it can read a data, write a data, and also it can read the DTC. DTC is nothing but a diagnostic trouble code. So all these operations can be done from the tester. All right. This is what the basic operation of DCM. And we all know that UDS is a protocol independent, but in our case now we are restricting it only to CAN. I'm going to show you. Fine. So this is the AutoSAR architecture. I've
Some network issue from your end.
this architecture to show where the DCM lies. Now is it clear?
Now somewhat clear, but we are facing the glitches.
Okay. Just a minute. Fine. Bhishma, now shall I? Is it clear?
Please. Yeah, please.
Fine. So just let me repeat. So this is, I've just given this AutoSAR architecture just to show where the DCM lies. So in the communication services, here is the DCM lies. All right. Fine. So related to diagnostics, we have these many modules. One is the Diagnostic Event Manager, which we call it as DEM. The other one is Diagnostics Communication Manager, that is DCM. Function Inhibition Manager, that is FIM, and DET. If you want a clear picture on what is DEM, we've already done a session on DEM. So you can have a look at it. So you'll get a clear idea of how to configure a DEM module. So we know that DEM module is used to log an error. All right. So now we'll get into DCM. So the primary responsibility, that is the main responsibility of a DCM, is when the data is requested. That is, if there is a request from the tester tool to the ECU, that request can either be a DTC status or it can be to read some DID values. It is nothing but data identifier values or write the values, anything it may be. So what will the DCM module does is it will accept the incoming request, all right, from the tester. Okay. So from the tester, it will accept the request. It will validate what is the exact service, and according to the validation, it will take action. Fine. So once we receive a request, it may send a positive response or negative response. So either case, it can send a response. Fine. So there are many UDS services, nearly 26 services which are available, in which the most commonly used services are these. The first one is diagnostic session control, which is given by the service ID 10. And second one is reading the DTC information, that is logging the error right from DEM. So that is given by the ID 19. And what we are going to focus is on read data by identifier. So the ID for the read data by identifier is 22, and writing data by identifier, it is given by the ID to E, service ID. All right. So next we'll see the data flow in the DCM. So what happens here is, as I've told you earlier, the tester tool is connected through the canvas to the ECU. So once the request reaches the PDR, it forwards to the DCM. This is the normal happening. So here, what happens is when the tester tool is connected to the canvas, it will pass through all these lower layers and then it reaches the PDR. This is the first thing which will happen. And then from the PDR, by the ID and the CAN message, it will forward it into the DCM. It is similar to the COM transfer. The same thing happens here. All right. So it will pass through all the lower layers and then it will reach the PDR. From the PDR, then it will be forwarded to the DCM. The DCM, it will take the action based on the requested message. All right. And then it will communicate with the software component through RTE if it is required. If in case of reading a data, we have to communicate to the software component. Or if we want to communicate, if you want to log an error, we can directly communicate to the DEM module. If you want to read the snapshot data, that is, in case of 19 services or other BSW modules. So in our case, what we have to do is once request is passed to the DCM, it will connect a services port to the application which we request, and then it will read the data from there. That is what will happen here. Fine. This is the data flow. Once it is done, it will revert it back in the same process. From the DCM, it will be forwarded to the PDR. PDR will just forward it to the lower layers, and finally, it will be reaching to the tester. This is what will happen here. All right. Fine. So this is the DCM modules. So in the DCM, we have few submodules, 3 submodules. One is diagnostic session layer, which we call it as DSL, diagnostic service dispatcher, that is DSD, and then the final one is DSP, diagnostic service processor. So these are the 3 layers of the DCM. First, when there is request from the tester, I've told you previously, it is forwarded from the lower layer to the PDR and finally it will be transmitted to the DCM. So that request, first initially it will reach only the DSL layer. Fine. So the major function of DSL is it will establish a session. When there is a particular request which comes to the DCM, it needs to serve the request, right? So what happens is it will create a separate area for the session so that no other sessions will interfere this particular session. For example, if I'm requesting for a session 19, what it will do is it will create a separate session. That is nothing but it will create a buffer so that no other session should use that part. Fine. For that case, this layer will help. Fine. And depending on the purpose, the sessions can be different. For example, we may be knowing that there is programming session in which if you want to flash any new application, there is a programming session which is available. And in case of some off-board diagnostics, maybe to debug. So in that case, we can go with extended diagnostic session. And if we don't require any special functionality, then we can directly go with the default session. So these are all done in the DSL. So these are all the things which will happen in DSL. And just to manage the session, what the DSL will do is, the DSL should know, right? So when to start and when to end a session. So starting of any diag session, that is, if the diagnostic session control request should be made, okay? So when the tester is about to send a request to the ECU, it should start the session with the ID 10. That is the first step which it has to do. This is how it will manage the session. It will know that, fine, there is some request is happening. Fine. If this request happens, the DSL, what will it do is, it will maintain the ECU in the same diagnostic session until it gets over. So once a response is sent, if the tester doesn't request for any other service again, then what will DSL do is, it will wait for some time and ends the current session and moves to the default session. All right. The tester will be requesting to the DSL to maintain the ECU in the same diagnostic session. So once, if suppose it receives a positive response, it will end the session and it will get into default session. And it will wait for some time before ending it. If it does not receive any request from the tester again, it will move back to the default session. So in this, we'll be having majorly concentrating on 3 timing parameters. The time which is elapsed since the last service is processed, right? That timing we will call it as S3 server time. So these are all the functions of DSL which I have explained. So here is the timing parameter. So from the tester, there is a service request message. Fine. I missed out one thing here. I'll just tell you. So service request message, and within a particular time, if it gets a positive response, it will send back the service response message. So that time is called as P2 time. Fine. This is one timing parameter. And if suppose there is a service request message from the tester to the ECU, and within that P2 time, if it does not receive any response, it will send back an NRC, that is negative response code 78, denoting that there is no response. Then what will happen is, if the P2 time is crossed, there will be additional timing added, that is P2 star. So even within that time, if there is no response, it will be continuously sending NRC 78. Fine. So until the P2 start time gets, gets to that end, what will happen is the NRC 78 will be continuously sending. If suppose it gets a response message, it will forward. Even if the P2 start time is crossed, what will happen? It will automatically get back to the default session. So this is what is regarding the P2 and P2 star time. All right. So there is a special service which is available in here, which is called as tester present service, which is denoted by the ID 3E. Fine. So if there is no service requested by the tester, for example, I'm requesting a service and I'm getting a response. I'm done with it. Now I don't have any request by the tester. So what will happen? Automatically it moves to the default session. But if in case the tester wants to maintain the current non-default session, right? So if it wants to maintain that session, what will happen is it will use this tester present case. Fine. I'll repeat. If I want the tester wants to maintain the default session, current default session, but I don't want to trigger any function now in the EC. Then what will happen is it will use a special service called tester present. So in this case, what will happen is DSL, that is the diagnostic session layer, will reset the server timer value to 0. So what happens? It won't be returning back to the default session until the process is complete. Fine. So putting this into a nutshell, the work of DSL is this: anything needed to start or to maintain or to end the session between the tester and the ECU, as intended, it shall be taken care by the DSL. And as I told you, there are 3 timing parameters related to the session. One is P2 server max, P2 start timing, and S3. So these timing parameters we should take care while configuration. All right. So this is all about DSL. The next layer is DST. So once a buffer has been created, that is a session has been created in the DSL, that information will be passed to the DST layer. DST is nothing but more of a dispatcher, diagnostic session dispatcher. So what it will do is, when it receives a request, it will send either positive response or sends negative response. So this is what is the function of this diagnostic service dispatcher. As we are going to see only the 22 service, that is read data by ID. If suppose if it is not configured and the tester tool wants that service, fine, I am requesting for a service that is 22, but it is not being configured. So what the DSD will do, it will check its service table whether it's been configured or not, and if it is configured, it will send a positive response down, or else it will send a negative response code. For example, maybe 0, I think it is 11. So NRC 11 will be forwarded down, which is a negative Why does it send a negative response? It is because you haven't configured that read data by ID. Fine. And also the function of DSD is that it will collect the response from the DSP, that is the above layer, right? I've showed you 3 layers. So from DSL, now we have switched to DSD. So DSD, it is responsible to send either positive or negative response code. So, and also it is responsible to collect the response from the DSP, right? It will collect the response from the DSP, and over here it will be adding the diagnostic service ID, and then it will transfer back to the DSL. Fine. This is also the responsibility of DSD. So in DSL, we have to configure a buffer, and here we have to take care of the few parameters, that is positive and negative response parameters. That is what we have to take it here. Fine. So in this DSD, there are many use cases. So like receiving if we receive a request message and we have to transmit a positive response, and once receiving request message, we can suppress it, we can send a negative response, we can suppress the negative response. So these are all the various use cases which are available. So in this, I'll just tell you like how we'll receive a request message and transmit a positive response, which is a standard use case. So when a request is received from the tester, first what will happen is that will be updated into the DCM buffer. That is the first step. And then the DSL, that is the lower layer, will intimate the above layer, DSD, of the received service request. All right. I'll just show you with the diagram. It will be a little more clear. So here in DSL, a request is received from the tester. All right. That will be updated into the TCM buffer. DSL will intimate DSD of the received service request. The intimation will pass here. What the DSD will do is it will check the validity, and then it will forward it for the processor in DSP. So once all the processing is completed in this part, DSD, again, it will gather the information from the DSP, positive response, and updates the DCM buffer and intimates the information to the DSL that I've updated the response which I got. Fine. This is the standard use case. Fine. So this is all about diagnostic service dispatcher. And the last one is DSP, that is diagnostic service processor. So once all these process has been done, if we receive the message into DSD, it will check for the format of the message. It will check what are the subfunction is supported or not in the service table. And finally, it will assemble the response all together. Fine. Assemble the message, leaving the response service ID, because the response service ID will be added by the DSD, and then it will be sent it down. So this is what happens. So in our case, it is read data by ID. It will reach the DSP. From the DSP, it will check from where to fetch the data, and from application software component, if it wants to fetch the data, it will create a service port. This will act as a client, that will act as a server. It will request for the service, it will provide the service. This will process and send it all the way down to the back to the tester. So these are all the modules here. And like how to configure the DCM module is that we'll first load the CDD file or the AirXML file into the tool. And as I've told you initially, in the DSL, the only thing we have to do is we have to configure the buffer size. So we'll configure the DCM buffer size to 4095. It is because DCM buffer is nothing but a location, right? Where we'll complete UDS service request that will be stored in that DCM buffer. So in the first frame, when we send the CAN multi-frame communication, in the first frame, 12 bits will be reserved for the complete IPDU size. Fine. So 2 to the power of 12, that is 4096 bytes. That is 0 to 4095. We'll be configuring the buffer size to 4095. This is what first you have to take care. And then you have to ensure whether your DEM client is established. Do check that if you, in case if you want to log the error, I mean, take the error from the DEM module, you have to establish this. Fine. DEM client reference. Check for this configuration. This is what you're going to do with DCM DSL configuration. And next is that DST configuration. So there will be many services which have been configured. So you have to ensure whether all the services are available in the DCM DST services. So for our use case, we're going to read data by ID. So what will we do is you will have many use cases, that is services, read data by ID, write data by ID, security access, and read DTC status. So you'll be having many services. In that, you just check whether your service is available. So whether it's properly configured. Once you've done with that step, the next step is you have to check whether the security access is configured properly. Fine. It will be having 4 sub-services. You have to check whether it is configured properly. That is sending, key, seed, all those things. You have to check it whether it is properly configured. This is what you're going to do in the DCM DSC. That is the second layer. And then finally, in DCM DSP. So in this dispatcher processor, you have to check the session timer is enabled or not. Fine. You have to check whether the S3 is enabled. That is the first thing. And you also have to check the timings are configured. As per the CDD file, you should check whether the P2 start timings all are properly configured in the 3 modes: default, extended, as well as programming mode. Fine. So once done with this, you can create a service port to read the data. Fine. Between the DCM and the application software component. Once you're connecting, just check whether it is syncing with the developer and validate, and you can generate the DCM module. So these are the processes which you'll be doing to generate the DCM module. Fine. So this is all about Diagnostic Communication Manager. Karthik?
Yeah, hi Samyukta. I think we'll take up any questions if you have on how do you want to configure or anything. We will try to take up questions.
Yes.
Yeah, okay. I think there are a few questions already. Samyukta, there's a question. How long it will send a 78 NRC?
How long it will actually it will send a 78 NRC. It will have we'll configure a P2 start timing. It will send an NRC until it gets a positive response within that P2 start timing.
So the general idea is that when you are sending a request and you're not getting a response in time, then it will give you that NRC, but you can update it. Okay, it will keep updating. Suppose in case the upper layer is handling some work, it can always tell that I'm handling some work. So in that case, the tester will wait. So it is not a fixed time. Okay. So Satish or Patel, yeah. Hello.
Hello. I
Yeah,
have
any
one question.
Sorry.
I have one question. Where we are going to configure the DID, the services we are going to configure in the DCM, but where we will configure the DID, whether in the DEM module or DCM module itself.
DID?
Yeah, DIDs where we will configure. How we will configure the DID. The services will be configured in the DCM module, but we can configure the DID. What is the how to configure it? How the DID will read the data, write the data.
You want some, say for example, you want do some read data like that. Is that your question?
Yes, yes.
Okay, I'll give you see, one of the most important things when we are you able to hear me? Abdul?
Yes, yes. Yes, I can hear.
So one of the most important things that we have to understand here is the CDD file. There is usually a CDD file which you load into the stack, okay, or the ECU extract. There is an ECU extract which you load into the stack based on the what I will call variant. Okay, there will be a CDD file and you'll have different variants and you load that into the stack. That will be step 1. Okay. Once you have this, then what happens is you will have all the modules configured on it. Like say, if you have a proper ECU extract, then the DCM module, all those things will be properly configured in by itself. All right. Our responsibility as a BSW engineer or a application handler, primarily when you are having this ECU extract intact is you will have to create a port interface. Okay, you'll have to choose the right port interface that will connect it with the application, and that is usually available in the in if you look at in the stack, it will be available in the port interfaces. Okay, so you will have to go to the DCM module, choose the right port interface, and create a port port interface. Once you do that, then you can connect with the application and start working on it. So the configuration, if you say what do you mean by configuring the DID, is the DID should be present in the CDD file, step one. If you load a proper ECU extract or a CDD, then what happens is it will you'll be able to create select the right port interface in the DCM, create a port and keep it, and the RTE you connect it. Okay, so that will be the process.
Yeah.
So you will have to talk to the application. Typically, when I'm saying you will have to talk to the application, DCM will have to talk to the application to read some data or something. So for that, that will be the process.
So the generated API will use to the application will use it and use the data, write the data accordingly.
Correct. So you will trigger. There will be a client server port, and the client request will come from the DCM. The application will have to respond to that particular request.
Okay, perfect. Thanks.
Okay, so from when you are connecting, the only thing that when you are choosing the port interface, after you choose, you can have a variety of port interfaces depending upon what kind of service. So that's why we didn't want to, like say, take a particular service and explain, but you can use a particular port interface, and once you identify the port interface in your DCM, it will be a client request. Okay.
Okay.
Done.
Hello.
Yeah.
Yeah, my question is the previous one, which the Suresh has had asked regarding the how long it will send NRC 78. So will we configure this in the tool like this many times?
Yes.
We'll
You will
configure.
have a parameter in the tool. In that tool, you will actually load what is the value that has to be given for that particular service. You will load that value.
Okay. So after that, it will it will go to the default, or we can write the code like general reject or something like that.
You can write
After
code. It
yes.
usually goes to the default, but what happens is you can write, like say that request, you can always look at it, and from the application you can control it.
Okay. Yeah. Thank you.
So, hello Karthik.
Yeah.
This is Arun. So,
Hello, Arun. Yeah.
can you show how to configure this DCM with a tool or any something?
We wanted to do that, Arun, but unfortunately, what happens is we want to have, we have taken a permission from EP to kind of showcase it in the webinar. We didn't get the response.
Okay.
That's why we had to kind of postpone this webinar also from last week. Okay, but we'll definitely get the I mean, it has to be officially approved by EB in order to kind of showcase it to a public forum. So that's why we couldn't
Understood.
do it. Okay. But we'll get the
So,
permission and we'll definitely do one, at least like say a read by identifier, and like say maybe for DTC, we'll try to log it and show it. We'll definitely do that. Okay.
yeah, at least for one service, at least it is very helpful for us.
Yes. We'll do that. I mean, like I said, we didn't get, since they are all on a holiday, we couldn't like say kind of get it organized, get an official permission.
Okay, and that's fine. And can you briefly explain, what is the, while Shamita explaining, she said NP, LP, IPDU like that. So, what exactly, this difference between NPDU, IPDU, and LPDU? Can you elaborate?
Okay. So the idea is what, all right. Okay. Can I just present my screen? Is it visible?
Yeah. No, not it.
Okay, I'm just sharing my screen. Can you see my screen?
Yes, it is visible now.
Yeah. Okay. Just one moment. Okay. What I'll try to do is, okay. See, when you have an application, correct?
Yes,
You
correct.
have an application layer, right? So in the
Yes.
application layer, what I will tell you in terms of a C language. Okay, so it will be like say
Okay, fine.
pretty easy to kind of visualize. All right. So in the
Okay, fine.
application, well, let's assume you have a data that needs to be sent to the it could be like say either way up or down, either way it's going to be the same story. Okay, so let's assume you
Okay,
have data to be sent, and let's assume this data to be dot status. All right.
okay, okay,
This dot status is like say, let's say it's a Boolean variable, just to keep it. Okay.
okay,
I will call this as a
okay,
signal. All right.
okay,
So
fine.
this is typically what we
Yes.
call as a signal. All right. And then
Okay,
what happens is in your COM module, all right, or in your DCM module, all right, what happens is
okay.
you combine many signals to form a PDU. Got it?
Yes, the signal group is.
All right. Okay. Not signal group actually. It's like say for example you have a CAN frame. Let's assume you have a CAN frame and you're using CAN as a communication. All right. A
Yes,
CAN
yes.
frame can like say for example if you have a signal of just 1 bit, you can have 64
Okay.
signals. Correct. So in
Yes,
your
correct.
COM module, what you can do is you can concatenate all these 64 signals together in a frame format as defined in your DBC. Correct.
Okay.
Okay,
Yes.
so because 8 bytes, CAN has got 8 bytes length, correct? So
Yes, yes,
maybe
yes,
0th
yes.
byte, first byte, like that till 63rd byte, you can have like say 64 signals, assuming each signal is 1 byte. Now in your DCM or COM
Okay.
module, you what happens is you concatenate. So this is called as a PDU. All right. And as long as
Okay.
in the
Yes.
services layer, it's called as NPDU.
Okay. Service layer, it is NPD. Okay.
Okay. So what happens
Okay.
is now you have a NPDU. Then what happens is it moves to your CAN IF module. Okay. Where it
Okay.
will get you add your CAN header.
Okay.
Typically, I will call you are adding your DLC concatenating. Okay, concatenating
Yes, yes.
DLC plus your CAN ID. Correct. So
Yes.
this is another type of PDU. All right. So it's called IPDU like that. All right.
IPD.
And
Okay.
then correct no Sangeeta. I mean Samyukta. And then it goes to your CAN driver. All right. Your lower level driver. All right. So where it is called as an LPDU, where you map the what do you call PDU to a what do you call hardware handle. All right.
Yes.
In simple embedded terms, it's nothing but your mailbox. Correct. Your CAN mailbox. Typically your CAN
Okay.
mailbox. So this is nothing. So every time what happens is at every when the data is passed from one module to another module, you add a header. So each when
Okay.
header is added, you have some protocol control PCI bit that gets added to it. So it's given a different
Yes,
name.
yes. Okay. So when it is in COM, it
Okay.
is NPDU, and after that, okay. Like
Uh,
NI.
in COM, it's IPDU. In CAN if it's
So it's
N
COM, it's LPDU, is it?
IPDU.
This
Above one
is
is
COM, it's
IPDU.
IPDU. Yeah. Okay. I mean,
Okay,
we
when
just
it is
got the
in COM, it is
names wrong.
NPDU,
Yeah.
and when it is in.
I think you can just Google it. It will give you an answer.
Okay,
Uh,
fine.
you can just actually, we have a webinar which is done on communication stack. You can just look at it. It will have all those details. Okay.
Okay,
Just in
okay, then
case you
I
are
will
not
refer it
able
to
to
that.
find it.
Yeah.
Yeah.
Okay,
And
fine.
Karthik, one question. So, for
Sure,
example,
sure.
if you want to communicate between two components, we will be having sender receiver or client server, right? So, in between this DCM and a application component, where we are creating the
Hmm.
interface.
The interface is created in the DCM.
So that will be done in the in which layer? Like we have DSL, DSP, and other, right? Because actually I am familiar with the
It
developer.
will be created in the topmost layer because that is okay.
Mhm.
Good. I'm
So I am
missing your
familiar
point.
with
I
the
list.
vector tool. Yeah. So actually, the client server or sender receiver, we use it to create in developer. But for a services, I mean DSW DID creation, after creating some parameters like buffer size and the sessions and all, automatically we are seeing that particular interface in developer. So that one confusion. So how it is?
See, there are two ways. There are actually two ways you can create. Okay. My choice. Okay. See, many a times what happens is, if you are working in the BSW stack, okay, you may not have the chance to get exposed to a developer at all. You may have to limit your scope only to a configurator.
Yeah.
All right. So you may not even get exposed to a. So how does it actually work? So you will have to just choose the interface, and you can create the interface from the developer or from the configurator. Both options are possible. All right. So the RT is the layer which is responsible for, like, say, connecting these two guys. But as far as the interface is concerned, you can either from here or there. Okay. So I will probably say, for example, I'm working in a DCM module and I don't even have an option to kind of work on a developer. Then I'll probably choose the interface from what is it called, configurator only. Okay, in the DCM module only. Okay. Did I answer your question, or you have, like, say, more?
Yeah, it's okay.
Oh. Can you see this?
Yes, we are able to see.
So when you add the PCI bytes, it's, and yes, so this is where it is. Okay. In the services, okay, in the here, when it is come in this layer, it is called, this is the services layer, it's IPDU. Between the services layer, when it is communicating between the services layer and the EC abstraction layer, it is your NPDU, and the lower layer, it is LPDU. Okay.
Okay.
And this is exactly what I'm also saying. I'm sorry, I missed the gentleman. You can actually create an AutoSAR port interface. See, bottom line, okay, bottom line, if you look at port interface is nothing but a function call or and a function definition in C programming, in terms of C programming, correct?
Right.
So idea is you create a port, and it's a client server interface. So you create a client port in your DCM, and for a particular port interface, and you just keep the port open. All right. When they kind of try to integrate the application, the integration team will kind of take this particular port, to choose the interface, and you'll connect it to the particular application. That they will do during integration. Got it?
Okay.
Okay.
Yeah.
And one more question. So in a CAN, we will be sending 8 bytes, right, Karthik? So in that, now you told, like, when a signal is coming from, once a signal is combined as a PDU, we will be having one header. Then in the network layer, we will be having one more header, like that, right? So in CAN frame, we will be sending 8 bytes of data. So in that 8 bytes of data, all this header information will also be present?
No.
Data.
Yeah. No. So here, if you look at it, there is signals, correct?
Yeah.
Okay. Can you see my screen just out of curiosity?
Yes.
Yeah. Okay. There are signals. Okay. So here, if you have, like, say, for example, a CAN frame, and it is, let us assume this particular CAN frame has got 8 bytes of data, and each signal is uint 8. All right. So it can accommodate 8. It can accommodate 8 bytes. Correct? No.
Yes.
So you can let's assume I have 8 signals, okay, which is 8 uint variables that are passed from RT. So these are the 8 signals that are coming from here. All right. In the COM module, what happens is these 8 signals are combined to form one PDU. That becomes your IPDU. All right. And the size of this IPDU will be 8 bytes.
Okay.
Because 8 signals, each signal is uint 8, so it becomes 8 bytes, correct? And till this layer, it is still, you have not added the CAN header, or, like, say, you have not added the DLC length and all those things. You just, like, say, have data. It's data here. All right. So now it comes to your PDR. In the PDO router, you take a decision whether it needs to be routed to CAN. Okay, now you have said it's a CAN frame and it's only 8 bytes. So what it will do is from the PDR, it will go to your CAN interface. In this module, what they will do is they will add your DLC and they will add your CAN ID. Okay, they will take the data when you load the ECU extract. From the ECU extract, they know, okay, this PDO has to be mapped to this particular CAN ID. They will map it and they will, like, say, convert it into a CAN frame. And they will map it. They will find out what is the lower layer mailbox. Okay, let's say, for example, you're using a PC387, just a board. Okay, and it has got, like, say, some 5 CAN channels. You need to map it to a particular CAN channel, correct? So it will map it to that particular CAN channel, lower layer. So that will be done here.
Okay. Yeah, thank you.
Yeah. Yeah. Any other questions? We'll definitely, like I said, we will take permission. We'll do a DCM configuration only on the tool. We'll probably create a half-an-hour module for that. We'll organize something.
Yeah.
On that. Yes. Any questions, guys? Team? Just check my. Okay, I'll just stop sharing. All right. If there are.
Yeah, we are clear.
Okay. All right then. Thank you so much for joining. We will meet you in yet another webinar next month on the first Thursday. Thank you so much for sparing your time. Have a very nice weekend and a very happy Diwali to all of you.
Thank you. Wish you the same. Thank you.